Hello, everyone, and welcome to our session on how low-code and no-code platforms can help transform actuarial data processes. Before we dive into that exciting topic, we have a bit of housekeeping to take care of. As participants in this conference, we are committed to adhering to strict antitrust laws to ensure a fair and competitive environment. Please avoid discussing pricing, market allocation, membership restrictions, product standardization, or anything that reduces competition. If any part of today's session veers into that territory, please leave the meeting and report the incident to the conference organizers. We also want to thank the sponsors of this conference, the Standard, Coherent, Decanter Group, and Passet. Without their support, we would not be here to share this information with you. We appreciate their contributions to making this event possible. Another important reminder, the views and opinions expressed in this session are those of the speakers, not those of our employees, sponsors, or any other entity. These are the ideas we believe in and wanted to share with you. With that, let's go through our agenda for today. We'll start by introducing ourselves, the topic at hand, and our goals for this session. Then we will dive into the core content. We'll cover a general comparative analysis of no-code, low-code, full-code options with their pros, cons, and best use cases. Then we'll share our real-world experience with successes and pitfalls, guidance around best practices and how to set up an effective center of excellence, and the solution landscape as of 2025, including the potential impact of AI. Finally, we'll wrap up with conclusions and leave time for Q&A. To be transparent, this is a pre-recorded presentation. That means we expect to be available in the chat to answer most questions live as they come in. Feel free to ask along the way, though we may save the more nuanced questions for the final Q&A segment. So first of all, who are we? My name is Anton Cotello, and I'm joined by my wonderful co-presenter, Mira Ensley-Field. We are consultants at Decanter Group with a combined 18 years of experience in automation and data analytics, including the last 7 years working across multiple actuarial transformation initiatives. During this time, we've had the opportunity to automate data pipelines for employee benefits, retirement plans, and individual annuities, implementing data quality checks, data curation, and transforming Excel-based tasks into streamlined, reliable solutions. Some other notable projects include experience studies, profitability analysis tools, pricing algorithms, GGY Access integrated model orchestration, and a wide range of financial reporting automation. What's our goal for today? What business problem are we trying to solve, and why is this discussion important? Let's start with the big picture. Actuaries rely heavily on data and on the technologies used to process that data. Traditionally, the actuarial tech stack has been dominated by Microsoft Excel, which is excellent for some purposes, but not so much for others. When actuaries need transparent, auditable, and efficient data workflows, or when they need to move away from manual copy-paste, dependency chaos, and a patchwork of VBA scripts, they often look for alternatives. One well-known alternative is to adopt full code solutions like Python with Git. The challenge is that many actuaries and business users will face a steep learning curve, and IT may disapprove of inconsistent coding standards or simply be unable to support those custom solutions. Should we teach actuaries how to code? Should we teach IT developers as many actuarial concepts as needed so they can build the data processes? The problem, of course, falls into a multi-industry decades-old tension, also known as the self-service versus shadow IT conundrum, where business users, in this case, actuaries and analysts, feel their needs are not fully met or not met in a timely manner and want more autonomy and more ownership, especially when those data needs evolve quickly and unpredictably. But when self-service does not exist or is not enough, shadow IT solutions proliferate, and they always do. That's the meme you see on the screen. And now the problem is they fall short of essential software engineering practices and the rigor required for scaling, cybersecurity, and general IT compliance. So, with those two challenges in mind, what skills to level up, and creativity, job satisfaction versus strong governance? How do we allow for self-service with the right guardrails? How do we empower non-technical users to solve problems quickly and reliably? And is there something to be part of that answer? Before we go further, let's define what Mira and I mean in this session when we use those buzzwords. Low code refers to data platforms that allow users and actuaries to build applications, data workflows, or automation primarily through visual interfaces. We're talking drag and drop components, configuration panels, and reusable pre-built logic, while still allowing or sometimes even requiring small amounts of code to handle more advanced logic or custom features. No code is very similar, but 100% visual development with no code or programming allowed. That said, pure no code is extremely rare in practice. Most, if not all, successful platforms eventually add low code features, plugins, or extensions to provide that needed flexibility at the edges. Also, for the scope of this session, when we say data processes, please think of complex end-to-end actuarial data needs. That is, reading your source data from a database, applying curation and validation steps, and eventually visualizing and reporting on your final output data. But also, very importantly, these complex workflows are not just about summarizing clean data. There is significant business logic we need to apply, dozens or even hundreds of formulas and transformation steps. Because of that scope and data needs, we're not considering tools like Tableau or Power BI in this no-code, full-code landscape discussion, or at least not by themselves, as they serve a more specific purpose. You will easily recognize that this session is not a sales pitch for any single platform. Our goal today is to share an honest perspective on how low-code and no-code platforms can help transform actuarial data processes with the right fit for the right use cases. We will unpack the trade-offs, pros, cons, strengths, limitations, and practical guidance to get the most value out of them. Also, disclaimer, when we say alternatives, we do not mean mutually exclusive choices. Most organizations will need and will use a diversified actuarial technology stack. It's normal for multiple tools to coexist, as different teams will have different needs, requirements, as well as budget and time constraints, which naturally leads us right into the next section.
Thanks, Anton. So Anton has talked through a problem statement of the age-old self-service conundrum. And in our situation, we have actuaries with their high utilization of data and complex data processes, but not necessarily all the expertise and time to focus on building robust code-based data processes. So with that, I'm going to go into some comparative analysis and use cases. But first, I want to take some time to go over the core requirements and nice-to-haves to have fresh and explicit in our mind when we're talking through these data processes. So the first of these is stakeholder satisfaction. It's of course imperative that both IT and actuaries feel confident and comfortable with the solution. Some of the terms that we've been using to describe data processes are processes that will be version controlled, reproducible, reliable, and automated. And those are our core requirements of any solution that we consider. In addition, IT especially tends to want processes that are version controlled, and they need those data processes to be maintainable and secure. Actuaries need solutions that are going to have low latency and be fast. And they also need solutions that are not extremely frustrating to work with and that do not require them to spend 4+ weeks learning new skills for these processes to be understandable and usable. In terms of scalability, when we think about solutions, the approach should have multiple lines of support for multiple lines of business without requiring major rework each time. We do not want a different solution for each business line. And one good goal to think of here in terms of what does good look like is how easy is it going to be for an actuary in one business line to be able to onboard relatively quickly to another area. Ideally, there's going to be a lot of parallels and similarities that are allowed between business lines, and it should not feel like an actuary has to practically join a new company every time that they want to switch teams. Rapid development. It's important that building and deploying new data processes should take weeks and not years. We're in a competitive and fast-moving industry, and we need to be able to be agile and able to quickly respond to market pressures, new data sources, and new data insights. In tandem with that, sustainable maintenance. In a similar vein, we need to be able to build out new data processes. We also need to be able to quickly refactor and adapt existing processes. A solution where you can quickly build something out, but to make any change is a huge effort or a huge amount of rework is not going to be a good solution. Customizability. Actuarial needs can be highly niche and extremely variable. So a solution, of course, is going to need to have strong out-of-the-box features, and most likely your actuaries are going to need some pretty customized logic for customized tasks that might not be supported out of the box. So that customizability feature is key. Cost effectiveness is, of course, another important one. We want to avoid large platform costs to the extent possible, and we also want to avoid having the need for a dedicated and extremely specialized and expensive DevOps team. And lastly, future ready. It's imperative that we're thinking into the future when we think about solutions. Solutions, of course, need to work with the status quo, and they also need to be compatible with your organization's strategic directions. At minimum, this probably means that the solution needs to integrate well with cloud environments, and you should be thinking always about how it will integrate with emerging technologies, as the field of technology is always changing. So next up, I want to talk through some comparisons. As my colleague Ant and I were putting this together this presentation, we realized that there's a lot of nuance when we talk about coding platforms. There really are no platforms that we could think of that have absolutely no way of using code to interact with them, though there are certainly platforms that make using code a difficult and arduous process. On the other side of things, even platforms that I think of as being code platforms that are built to help you write and maintain code, like Visual Studio Code or Azure DevOps, they, of course, have user interfaces, and there are many things you can do on those coding platforms by clicking buttons instead of writing code. So that all being said, what we're talking about with these platforms is that there are platforms where the primary strength and marketability comes from a robustly built-out user interface, versus there are platforms that are more built for code-minded developers to be able to write and develop code with ease. So that's what we mean here by no-code and high-code platforms, and we do acknowledge that that is a spectrum of sorts. So next, we're going to kind of talk through some of the trade-offs that we're going to think of when we're considering platforms that are no-code and high-code. And the ones we're going to focus on are learnability, cost, customization, performance, and collaboration. So first up, learnability and barrier to entry. No-code platforms are typically the easiest to learn. They're designed for speed and simplicity so that users can get started quickly without technical expertise. A good low-code platform is user-friendly. That means that the interface is designed to minimize users needing to look up and read documentation. There's a lot you can do on a well-designed low-code platform without having to ever read or touch a user manual. Coding, on the other hand, tends to have a very steep learning curve. All coders have it drilled into them time and time again that often the starting point is to read the documentation. It often takes years at best of dedicated effort to really truly develop coding expertise, and you really just cannot be proficient at most coding languages if you're only using it for a few months. You can take this general framework a bit further within a coding platform, and that some coding languages are higher level than others and require more years to develop expertise and have their own performance, customizability, etc. trade-offs. But for now, we'll just drill into this point that it is far, far easier to learn and become an expert in a user interface platform than the typical coding language. We'll also note there's a few other variables here, like with user interface platforms that have a high market presence. They're often easier to learn because they provide a lot of tutorials. And while there's coding languages that have a lot of support or a lot of community on Stack Exchange or similar platforms, with built-in user visual platforms, you typically can also get vendor support that can help you quickly work through any problems and help you out with maintaining a fast learning curve. So next, we'll talk about the cost of platform. So both no-code and low-code platforms typically do come with licensing costs, and they don't typically require specialized developers to maintain workflows. Coding languages themselves, on the other hand, are usually open source, which means no platform fees, but hiring and retaining skilled developers can be quite expensive. Additionally, if you're going to have an enterprise level coding as a solution for data processes, you're still going to need some kind of platform like VSC or Azure DevOps, and the enterprise level for those platforms is not free. So there's still at some point going to be some licensing costs that need to be paid. In terms of customization, no-code solutions tend to be highly constrained by the platform's capabilities. And low-code platforms have this kind of backdoor where you can use coding to get around these constraints to a degree, but still they tend to have a bit more constraints than just writing a process in pure code. So coding does provide that greatest freedom of very few constraints on what you can build. And to quote an old manager of mine, with software, you can do anything, but that doesn't always mean it's a good idea. So moving on to performance, for very large data sets and highly complex tasks, user interfaces can at times struggle if they're attempting to show you a data set every time you do a small operation to it. And that can be an issue at times in terms of performance. Coding generally delivers better performance for those scenarios, but this, of course, is all assuming that your developer team has the expertise to write very efficient code. One thing about visual platforms is that behind the scenes, assuming you've picked a good platform, they really ought to have a lot of optimization algorithms built in so that users are essentially triggering efficient data processes when they create operations through the user interface. So generally performance, I would tend to believe you might get a bit of better performance from using a coding platform, but I think it's just worth pointing out that this might depend on the expertise of your DevOps team and that there's a lot of visual platforms that have a lot of really great built-in optimization features. The other caveat that we have to talk about with performance is it matters a lot about whether we're talking about a cloud platform or a desktop platform, and whether your code or script is running locally versus on the cloud. You can, of course, do far more complicated operations if you have cloud compute and cloud storage that has some kind of auto-scaling functionality. And regardless of whether you're going with a low code or a full code project, you're probably going to want to choose a cloud platform as a way of doing your compute and data storage. And then lastly, to talk about collaboration. No-code platforms generally make collaboration pretty easy among stakeholders who learn the tool and have the license. Coding, for people who like to learn how to code and know how to do it, can be a great way to collaborate. And there's a lot of software like Git that makes this pretty easy. However, there's a pretty high barrier to entry in terms of getting the proficiency to use Git as a version control system to collaborate with, as well as learning the coding languages that you want to collaborate with your colleagues on. And then additionally, it often does require to have very good coders and very good documentation practices for people to be able to really maintain code that's written by anyone other than themselves. And typically, collaboration between business and a code solution for a data process requires that there's going to be a team role to gather requirements, do UAT, etc. And it's much more of an iterative cycle of the business working with the software team to develop a solution. Versus one thing about these visual platforms is that they typically allow everyone to be working on the same platform together, and it's less of this feedback cycle between business and IT. So in short, each approach has strengths and weaknesses. No-code, low-code platforms prioritize accessibility and speed of development, while coding offers perhaps maximum flexibility and generally better performance, but at a far higher complexity. So the question of what is best, the answer, of course, is that it depends and that there's a lot to consider. And I'm going to highlight a few key areas of questions that we asked ourselves as we are going through this process. So some of these criteria and these things to be thinking about are first and probably foremost primary users. So you want to be asking yourself questions about like, who is your primary user group? Are they technical or are they non-technical? Do they know how to code and do they want to learn how to code? Do they want to learn a new platform? And perhaps most importantly, do they have the ability to and need to understand and modify data processes themselves? You'll also want to be thinking questions in terms of scale and performance. So what kinds of workloads are being handled by your data processes? Is it ETL? Is it analytics? Is it modeling? Is it a mixture of all of the above? Are you typically dealing with thousands, millions, or billions of rows? And another good question to be asking is how critical is performance optimization for the business outcome? Is speed the most important thing to consider, or is understanding and being able to quickly modify data processes more important? In terms of customization, it's good to know and understand how complicated your workflows are. Are they mostly based in Excel? Are they mostly SQL statements? Are they fully built out and coded repositories? Is there a high need for custom logic and advanced transformations? Do these processes potentially need to integrate with very niche actuarial tools or very niche actuarial modeling software? And I also want to mention, of course, support. Open source code can be great for a lot of things, but Stack Exchange doesn't always deliver solutions 24/7, and bugs, if you catch them, don't always get patched right away. UI platforms tend to offer 24/7 support, as well as an account manager to help you resolve issues you encounter. Of course, these are features you need to pay for, but depending on the urgency of speed in your data processes and issues getting resolved, thinking about support for your solution may be an important factor as well. So next, we're going to talk about our experience, some of the lessons we've learned, and some of the conclusions we've drawn. So I'm going to start out by revisiting that table from the early use case where we were looking into considerations and criteria. So first off is primary users. For us, actuaries are the primary users, not developers. When we framed the problem statement earlier that there is sometimes tension here between business and IT, that certainly is not unique to this industry. But for us, actuaries were driving the need to better understand data processes. And part of that is their curious nature and their drive to understand. And another part is that they often really do truly need to make updates, corrections, and rethink ways of doing things. To do their job effectively, there comes a point in the data transformation before models are run where actuaries truly do need to be able to look in and understand what's going on in their data. Actuaries have an extremely high willingness and ability to learn, but becoming coding experts is simply unrealistic given their busy schedules and their already extensive areas of expertise. In terms of scale and performance, earlier we presented our problem as wanting to create data processes that were version controlled, reproducible, reliable, and automatable. The main part of our data processes that were the target of our work was not doing true ETL and source system ingestion, but upstream of those, or downstream of those. For us, IT is handling data source ingestion very well, but that typically is not an area where actuaries need to understand all the details and need to be able to modify it themselves. Accordingly, the scales of data that we're talking about tend to deal with rows that are typically in the thousands and occasionally in millions. And the emphasis for us is less on absolutely maximizing computational performance of these processes, but having processes that are easy to understand and easy to modify if they need to be updated. For customization, most of the processes that we are targeting were a mixture of manual instructions that rely heavily on Excel, as well as SQL and definitely some Python as well. So we for sure had a mixture of use cases of data processes, but we found that the vast majority of the transformations that actuaries need to modify or understand are fairly common and fairly simple use cases, but most workflows, at least a few times, have something that is pretty complicated and pretty difficult to do. So we've been thinking of this as a type of 80-20 rule, where 80% of the operations that need to be done are pretty similar, but there's about 20% that are significantly more involved. And then, of course, more of a miscellaneous feature, but probably one that's familiar to many people here. To fully automate the processes, which again was one of the things that was very important to us, we needed there to be hands-off, and that required that there is integration with existing software. And so while we want to get as much out-of-the-box native integration as possible, given some of the more niche actuarial modeling software that our organization uses, we understood that we may need to do some back-end coding ourselves to really meet that complete integration need. So with that, we want to move in and talk about how things are going. So early in this presentation, we laid out some options for making more user data friendly processes, including having IT work on becoming more customer centric, as well as upskilling actuaries to become more technical, as well as having this collaborative low code platform. And the solution that we ended up going with is that we got a license to the platform Dataiku, which is one of the many low code platforms out there. And so when we're talking about how is this particular solution working for us, I think one of the first some of the key features that we're thinking about that were the goals of this were, again, that learnability, performance, customizability, and collaboration. And the first question that we're asking ourselves is, are actuaries contributing more and more to these low-code, no-code projects? So I think this question answers a lot of those key features we outlined earlier. In particular, it will talk about learnability and barrier to entry. Are actuaries actually learning the new platform well enough to be able to meaningfully contribute, as well as customization and, of course, collaboration. So the key goal of getting a low-code platform for us was that it would allow us to run data transformation processes end to end, some of which are pretty complicated Excel and involve pretty complicated SQL scripts as well. And we wanted actuaries to be major contributors, not just requirement givers as they had been in the past. So far, we have productionalized 3 processes on Dataiku, our platform of choice, that has replaced a large Python repository that had formerly been used. And this Python repository hosted a number of SQL stored procedures as well. So this former Python solution, actuaries rarely contribute to the previous code-based processes that Dataiku has replaced. And I did go ahead and look up, and 2/3 of the last changes to these processes that are productionalized were done by actuaries themselves and not by developers. So to me, especially in terms of learnability and collaboration, that's a huge win, and that is really the main goal of making the switch to a visual platform. I think it's also worth noting that none of the actuaries have used Dataiku before, and now, a few years in, they're the ones directly making changes to their data processes in production. The next question to ask ourselves about how our platform is performing is whether these data processes are entirely created through the user interface. So while, as I just pointed out, actuaries have made most of the recent change into these processes, they have not built out these processes from scratch. Typically, it's alongside developers where we've converted these code processes to these Dataiku processes. And we have indeed had to do some customized backend coding solutions for some of these data processes to be able to run end-to-end fully automated smoothly. So on the one hand, this can come across as a major shortcoming, and that is at odds in some part with my earlier praise of learnability and collaboration, and that we are still using code on this platform. But in practice, actuarial processes, logic, and actuarial modeling software especially, really truly is extraordinarily niche. So we are very glad to have a platform that's able to accomplish most of what is required in terms of data transformation using out-of-the-box features, and that we do have the ability to do some customization when we need to. And then in terms of performance, I do want to point out that we're not necessarily comparing apples to apples here when we compare our new Dataiku data transformation processes to their former code counterparts. We do run end-to-end processes faster, but a large part of this is because we put a lot of effort to automate all parts of these runs and eliminate any kinds of manual handoffs wherever possible. So by having this visual platform where actuaries themselves are in charge of these processes, they're able to kick off these processes and run them end-to-end themselves. And so though some individual parts of the process may take longer using a visual platform instead of code, the entire end-to-end run is faster than it was before. So while code solutions may be faster in a more reductional sense of each operation, automation that has been allowed by the visual platform that is usable by many stakeholders has been able to allow us to increase the speed of our data processes. So generally, we feel pretty good about our solution so far. And that all being said, I do want to talk through some of the pitfalls we've faced and some of the lessons that we've been learning as we've gone along. So first of all, overusing code, especially when there's built-in features available. There were certainly times where we needed to build out a feature to the platform, and it was extremely important that we didn't give actuaries a completely no-code platform because IT occasionally does need to work on helping with integration, as there are some extremely niche operations that were easily to implement in code. But we've also kind of faced the issue of because you can use code on the platform, it makes it easy for people who are proficient with code to want to use code instead of having to learn the visual built-in features. So especially when you have a developer that's working on the process, they really often can more quickly write a SQL statement than find a user interface equivalent of doing the same operation. And there's some ambiguity introduced by there being multiple ways of achieving the same outcome, especially if you're already familiar with the coding way of getting that outcome. However, the thing that we try to focus on is that we're trying to build data processes that are easy to maintain and update for the end user. And so even if it's easier for a developer to build it out using code, it really will be best practice and more maintainable in the long term if you avoid using code and use the built-in features instead. So exemplified here is an entirely unnecessary function to tell if a number is even. This is humorously written because it's not a good implementation of such a function. But the idea here is that there's a lot of simple operations that you may know how to do in code without looking it up. But it's still good use of the platform built-in features, even though there are often multiple ways of doing something. And the first time you do it, you will have to click around to learn how to do it. Another pitfall we face is overextension. So when a platform becomes really familiar, and especially if you as a user have a lot of permissions and familiarity with that platform, it can be very easy and convenient to use it for everything. So one thing we've faced is that because we're doing these downstream data processing tasks, if you as a user find a data issue and you're able to quickly figure out how to fix it in the platform, you may simply decide to fix it in the platform instead of communicating it to the appropriate upstream resource. And while, of course, it's good that the platform is able to fix some of these data problems that we have, it would be better if we work on fixing data ingestion issues where the data is ingested and not downstream of it. And so the idea of Maslow's hammer, I think, is useful here. If the only tool you have is a hammer, you tend to see every problem as a nail. If you have this excellent platform that you've become very comfortable using, it can be tempting to use it for everything, even when that wasn't the intended purpose of that platform in your tech stack. Another pitfall we faced is this dichotomy between flexibility and standardization. While vendors typically provide a lot of documentation and community support forums and market their tools as being extremely flexible and customizable, this can be a downfall to an extent, and that there's multiple ways of achieving the same outcome. Of course, it's preferable for there to be lots of ways of doing something rather than zero ways, but it can become confusing on your platform if different users and business lines all solve the same problem 5 different ways. This problem is certainly not unique to visual platforms. We see the same thing really with coding processes as well, but having in-house best practices or an in-house help desk can be a really useful way of trying to standardize some of the ways of solving problems so that we're able to maintain similarities of solutions between different business lines and different users. And of course, in addition to some of the general positives of increasing standardization, it can also speed up delivery if all of your users aren't constantly having to reinvent the wheel when they encounter a particularly difficult data transformation that they need to learn how to do using a user interface. And the last pitfall is more of a comment about how user interfaces and Git tend to work out together. So developers rightfully generally really like Git as a version control system. It's been tested and perfected over many decades. And user interfaces, we've noticed, are also increasingly being backed by Git repositories. However, our experience has been that visual interfaces tend to produce a lot of lines of code, even for fairly insignificant and sometimes entirely irrelevant changes. And of course, we like that every change to any change you make to a data process is going to be tracked. But a lot of the tracking records that we found can be fairly superfluous. So sometimes you may end up scrolling through 50 lines of changes because someone clicked into a column and filtered by a value. And familiarity with using tools to update and document the updates to your project is still really important, even when in theory, every change ever made to your visual project is being tracked. So with that, I'll hand it back to Anton to discuss some best practices as well as Center of Excellences.
Thanks, Mira. So if we discussed things you want to avoid, it's also important to discuss what you want to foster and implement consistently. I will not go into what I think your agreed best practices should be, but every organization either has or aims to establish its own set of best practices. This can include how to document solutions, coding conventions, and formatting. Some best practices are also tool specific, as in if you want outcome X, use feature A instead of feature B, and many other practices related to how to manage data governance, pull requests, testing access templates, and so on. All these elements are essential, but the challenge is making them clear, repeatable, and widely adopted throughout the organization. This is where a well-designed Center of Excellence, or COE, can be transformative. So let's discuss some ideas to make the most out of your COE. To make this section less vague and a bit more grounded, I'm going to assume that you are part of a large insurance company that has an Excel-based tech stack and you have decided to adopt a new low-code data platform. I'm also going to assume that this is happening after completing your ROI assessment and that you have already selected a number of good use cases that are a good fit based on the criteria we previously discussed, like no appetite for full code, room for automation, gaps in data engineering, and other specifics to your case. I'm going to talk through 7 ideas to help you set up your COE properly. Number 1, mission, scope, and boundaries. A COE should not be a best practices police force, nor a group of experts locked in an ivory tower. We want it to be an engine for collaboration that translates platform capabilities into real outcomes. The COE needs clarity about its own mission and the role that this new data platform is supposed to fulfill. What problem does this platform solve? Are we creating capacity by reducing manual work? Are we enabling brand new advanced analytics? Are we trying to unify fragmented systems? Without a clear mission, COEs drift into becoming generic support desks. A strong COE has clearly defined what it owns, what it supports, and what it enables. For example, it owns standards and governance, it supports onboarding and best practices, and it enables others to build with confidence. Second, build a cross-functional COE. A common mistake I see is staffing a COE solely with technical engineers. A successful COE blends platform expertise with business translators and change management leaders. Platform specialists understand the architecture and performance. Business translators ensure the COE's work aligns with relevant use cases, and change management leaders drive communication and training. This combination ensures the COE becomes a bridge between technology and the people who need it. Third, start with just a few use cases. Adoption grows through visible wins. The COE should prioritize a small number of high-value, high-paying use cases that demonstrate the platform's strengths. When people see value quickly, they come to the platform out of interest, not obligation. Fourth, establish lightweight standards. Governance often gets a bad reputation for slowing teams down. The best COEs design standards that feel like guardrails, not walls. A good rule of thumb, standards should be just enough to maintain quality and trust. This includes naming conventions, versioning practices, testing expectations, and documentation templates that are easy to follow. Number 5, training, enablement, and community. A COE's strength is not in doing the work, but in enabling others to do it. This could mean hands-on training sessions focused on relevant topics, weekly office hours, solution templates, and internal communities of practice. People adopt tools when they feel supported, when resources are easy to find and access, and when they can learn from peers. Sixth, measure what matters and communicate progress. The COE should report on 2 types of metrics. You have, of course, usage metrics, active users, pipelines deployed, but also impact metrics, hours saved, errors reduced, time to insight improved. And measurement is only half the work. The COE must communicate wins regularly and using business language that both leadership and users can understand. Finally, make continuous improvement part of the culture. Technology evolves, business needs change, and a great COE should treat its operating model as a living product with feedback loops and periodic updates to ensure that it stays aligned with the organization's goals rather than becoming a static bureaucracy. In closing, with the right COE, a new data platform becomes not just a technology investment, but a capability that transforms how the organization works, learns, and innovates. Moving on to part 4, I'd like to walk you through a comparative analysis of several data platforms across the spectrum. My goal is to give you a clear, structured way of understanding how these tools fit into different parts of the data value chain and how they compare in terms of coding requirements. So let me start with the idea behind this table. The first column on the left lists the platforms, and we have 1 row for each platform. The column in the middle describes each tool as it relates to their basic functionality and value proposition. And on the last column, I have a coding requirement score 1 through 4. Very simple, intuitive scale. 1 means true no code, and like we said, we don't really have any. 2 means low code, so visual workflows with optional lightweight scripting. Number 3 means hybrid, so a mix of visual components, but also a strong integration with advanced scripting. And number 4 would mean full code, so primarily a coding environment with minimal visual tooling. This, of course, is not a good or bad scale, just a description of the interface and philosophy of each solution. So let's go one by one. Alteryx, score of 2, has a user-friendly drag-and-drop interface. It excels at data prep, blending, and analytics automation. It is very visual, and also you can write small scripts. The environment is fundamentally designed as a low-code tool. Alteryx is often used as a bridge between Excel workflows and more automated data pipelines. SAS EG, this is a classic in insurance and actuarial environments. It provides a low-code visual interface on top of SAS. It offers point-and-click tasks for joins, data prep, modeling, and reporting. But underneath it all, everything ultimately becomes SAS code. It's reliable, auditable, and it fits well in structured, large enterprise environments. The key limitation is that EG is not cloud native and doesn't naturally integrate with modern Python-based modeling or big data workflows. SAS Vaya represents SAS modern cloud platform. Unlike EG, Vaya embraces multiple languages workflows. SAS, Python, R, and SQL can all coexist. It still offers governance, visual pipelines, integrated machine learning, and production deployment features. It is therefore a hybrid platform, so it earns a score of 3. For actuarial teams still invested in SAS but wanted to modernize, this could be a natural evolution path. DataQ is one of the strongest hybrid platforms on the market today. It offers visual recipes for data prep, pipelines, modeling, and monitoring, while also supporting Python, R, SQL, and Spark. It follows that middle ground where analysts can work visually, while data scientists can write code in the same project. DataQ is end-to-end, ingestion, transformations, modeling, ML, dashboards, and governance. That combination places DataQ at a score of 3. 9 is an open source alternative that fills a similar niche to DataQ. Its node-based workflow interface is intuitive, and it supports Python, R, and Java extensions. It handles ETL, data prep, and live deployment. It is cost-effective and flexible, but may require more technical setup for enterprise-scale workflows. It sits in the hybrid category, also at a score of 3. It can be appealing to teams that want open source governance and visual workflows without a large licensing commitment. Finally, Databricks is a full-code, cloud-native platform built on Apache Spark. It specializes in big data processing, distributed compute, machine learning, and orchestrated pipelines. Everything here revolves around notebooks, Python, SQL, Spark, R, or Scala. It earns a score of 4 because it requires technical skills. Databricks is not so much designed for citizen analysts, but in the hands of data engineers and actuaries who code and modelers, it can replace an entire legacy stack. And local Python would be the full code end of the spectrum in its purest form. Therefore, it gets a score of 4, obviously. Running Python on your laptop using Pandas, NumPy, Jupyter, scikit-learn gives you maximum flexibility, but it lacks governance, deployment, scheduling, and other large data capabilities, unless combined with cloud tools, but it would just be not local Python then. And finally, as a bonus track, Excel. In case anybody was curious, or if you're going to tell a coworker about the 1 through 4 scale, and they ask you, where does Excel fit in that spectrum? Well, first, Excel is not a data platform, as it does not provide governance or reproducible pipelines. But if we still want to place it in the scale, This may surprise you, but I could say it's probably a 3. If you're using pre-built steps on Power Query, then creating pivot tables via drag and drop, and then inserting new charts by clicking buttons is going to feel like a 1 or 2, so very much low code or even no code. Instead, if you're writing really long, dynamic, complex formulas, and then combining that with heavy VBA scripting, it will feel much more like a 3 or even a 4. So it depends. Finally, it is worth mentioning that there are ways to elevate Excel, and we have other sessions, for example, to talk about Excel Wins, which is a Python integration library that lets you call Python from Excel and vice versa. And second is Coherent, a platform to upload a workbook and convert it into an API you can connect to. Last item before we wrap up this part 4, you might be wondering, how is AI going to reshape this entire landscape? Will these conclusions still be true or outdated 2 years from now? And of course, this is a speculation, as these tools are evolving incredibly fast, and it ties into that larger debate we all hear. Is AI going to replace every job or maybe destroy the world? Our view as of 2025 is measured. We believe AI will make everything easier, but nothing free. It won't suddenly make full code platforms universally superior, nor it will eliminate the need for low code tools. Yes, AI can write Python, but it's also being embedded directly into visual platforms. And even with excellent AI assistance, we still need human oversight, requirements, checks, governance, and judgment. So we are optimistic about what AI can do, but we don't see it making one side of the spectrum win. Instead, it raises the bar for every platform. Finally, conclusions. Low-code and no-code platforms are not magical solutions. They will not eliminate the need for robust engineering practices, nor will they transform every actuary into a technologist. They do not fully replace Python, SQL, or other traditional ETL tools, or even Excel for that matter. But when used appropriately for the right use cases, based on parameters discussed in this session, they do fill a critical role in the actuarial technology ecosystem. They improve transparency for domain experts, improve auditability, lighten the burden on IT, and bring structure and automation to messy processes. And one final thought, because it's way too easy to get absorbed in technology and lose sight of the bigger picture, we want to end with a reminder. At the end of the day, no matter what your tech stack looks like, none of these tools replace the fundamentals. We still need to commit to a continuous improvement mindset, focus on customer value, engage and empower employees, and align work to our business strategic goals. Those principles matter more than any specific platform. Thank you all for your time today. We hope you found this session informative, maybe even inspiring. With that, we will transition into our final round of live Q&A. Thank you so much. See you there.